Hello everyone. In this lecture, fifth lecture for information theory and coding, we will discuss joint entropy, conditional entropies and mutual information, and relative entropy also. That was the last topic of lecture 4, which was not covered at that time. We will start from the relative entropy. Okay. In relative entropy, see, when we are proving the properties of entropy, that is the bounding of H log of n base 2 when source was equiprobable. Then using this thing, we are taking a help of a inequality log of x less than equal to x minus 1, and we have assumed one quantity at that time, that is probability. This is k is equal to 0 to n minus 1 summation probability p k log base 2 q k upon p k, and we have proved that this quantity is always negative. Okay. What was this quantity? Okay. When here we have taken a source S with their symbols S naught, S 1 up to S n minus 1, and P k is the probability distribution, that is P naught, P 1 and P n minus 1. Okay. And Q k, this is P k, Q k was Q naught, Q 1 up to Q n minus 1, that is also another probability distribution of the same source. Okay. At a time, suppose this is the probability distribution taken at a time. Okay. Suppose same source have another distribution, that is with the probability q naught, q 1, q 2 up to q n minus 1. In that proving, we have taken this is as a equiprobable case. Then we have proved that H is always less than equal to log n base 2. Okay. Now, here this quantity, okay, if we take it as summation k is equal to 0 to n minus 1 p k log base 2 p k upon q k, suppose. Okay. Then because this is less than equal to 0, it is a negative quantity, then it becomes a positive quantity. Okay. Here we are calculating the entropy of the source S for the probability distribution p k, okay, in respect to in relative to another probability distribution q k, both probability distribution given for the same source. Then entropy of the same source for one probability distribution in relation with respect to the another probability distribution. Okay. Then this is nothing but the relative entropy. This is the relative entropy, and it is always positive. Okay. And when p k equals to q k, suppose p k equals to q k, then relative entropy R e equals to आपका log 1 0. So, relative entropy will become 0. Okay. Then this is equality will hold. Okay. Then this is all about the relative entropy, when we will calculate the entropy for the source with one probability distribution in respect to the other probability distribution. Okay. Now, come to the next, that is the joint probability. Okay. See, the concept of joint probability came, suppose this is a channel medium, okay. It is accepting some symbols from a source x and giving some symbols at the output. Okay. X is also work as a source, you know. and in the same way y is also working as another source. Okay. This is the source with symbols x naught, x 1 up to x n minus 1, and y may be a source with symbols y naught, y 1 up to y m minus 1. Suppose this is the set for output y. Okay. Then if you need to calculate the joint entropy, then we need such example. Okay. Now, before finding the joint entropy, we will discuss the joint probabilities and its properties. Okay. See, suppose there is a symbol xj and another symbol yk. Input is xj, output is yk, suppose. Okay. Then joint probability of event when input is xj, output is yk. Okay. These are not statistically independent, but actually they are dependent. Okay. Y is dependent on x. Okay. So, we cannot say that this is p xj into p yk. Okay. We will use here conditional probability p yk upon xj into p xj. Okay. This will be the joint probability of the event when input is xj and output is yk. Okay. And this conditional probability when output is yk when input xj is known. Okay. Now, their properties, then we know that summation of p xj yk over j equals to 0 to n minus 1, k equals to 0 to m minus 1, this is equals to always equals to 1. Okay. But if we calculate this p xj yk over summation, suppose k equals to 0 to m minus 1, then this equals to p xj. Okay. Another, when summation over j is equal to 0 to n minus 1, joint probability p xj yk, it becomes p yk. These properties will be needed in next lectures. So, we can discuss not in next lectures, but in the next slides. So, we are discussing this. Okay. Similarly, conditional probabilities. Okay. Then this one. Okay. One property like that p xj yk is equal to p yk upon xj into p xj. Similarly, it is also true that it is equivalent to p xj upon yk into p yk. Okay. Then this become one property. Okay. This can be used when we are converting from p yk upon xj to p xj upon yk. Okay. This is the main property. Okay. And now come to the next, that is the equation for the joint entropy of two sources. The same sources x and y, x as a input source for the channel, y as the output source for that channel. Okay. We can calculate the entropy of the joint source x and y. Okay. Then its joint probability, that is the p xj yk. If probability is known of the joint source, then its entropy h of xy, this is nothing but the similarly here will be double summation, because double variable j is equal to 0 to n minus 1, k is equal to 0 to m minus 1, p x j y k, probability of that event occurring jointly into log of base 2 1 upon p x j y k. This is the equation for the joint entropy of two sources. Okay. Here p x j y k we can put its value like this also, p x j y k equals to p y k upon x j into p x j, or p x j upon y k into p y k. These values can be put here, okay, if needed. Okay. Now, next is the Venn diagram. See, for the same channel where x is input, y is output, and we are calculating their joint entropy x and y, and x and y they are mutually dependent also, they are not statistically independent, but dependent. Okay. Then suppose this is the entropy of x, okay. This is h x. Suppose this is the source x with their symbols, and we are taking as a entropy of x, and this is entropy of y, okay. Because they are dependent, then when we are giving some symbols from x to channel, then it may possible that same symbols pass to the output, okay. But it is also possible that some symbols from x they are corrupted at the channel, and at the output we are getting different symbols, okay. Then same symbols, that region covered here, this is the common area, okay. When x this is known, okay, entropy of x when y known, h x upon y, okay. When y known, then entropy of x can be calculated, okay. This is this area, okay, and this part is nothing but the h y by x, that is the entropy of y when x known, okay. Okay. Then h x, h y, h x upon y, then it needed conditional probability p x upon y. Here it needed conditional probability p y by x, okay. And its joint entropy, suppose this region common area, this is I x y suppose, okay. Then joint entropy h x y will be equivalent to what? Equivalent to what? H x, this is completely h x, and remaining part of this, that is h y by x, or suppose h y taken completely, and then remaining part of this one of h x, then this is nothing but the h x upon y, okay. And in terms of I x y, this is nothing but the h x plus h y, h x plus h y, okay. Then this common part taken 2 times, then one time it can be reduced, okay, so that it become the joint entropy, okay. For h x y we have given the expression in terms of p x j p y k p x j and y k, that is the joint probability. Similarly, h x probability for source x given, h x can be calculated. For source y probabilities for source y given, then h y can be calculated. Now, these are the conditional entropies h y by x, h x upon y and so on I x y, that expressions can be derived in the next slides. Okay. Relationship we have discussed through the Venn diagram, how joint entropy, okay. That shaded region in that diagram, it was I x y. Okay. Here this I x y known as the mutual information of the source x with y, okay, jointly. Okay. That expression we will calculate, and relationship already we have discussed. Now, equations for conditional entropies, that is h x upon y and h y by x. Okay. Now, come to the h x upon y, then h x upon y are when y is equal to y k, y is equal to y k. Y is equal to one symbol y k. Okay. This is not the h x upon y, but it is a one term that through that we will calculate the h x upon y. Okay. This is h x upon y when y is equal to y k. Okay. This can be calculated with the same method, that is summation, because there is only x is varying, then j is equal to 0 to n minus 1 probability p x j upon y k. Y k is fixed, okay, for a fixed y k, into log of base 2 1 upon p x j upon y k. Here also y k is fixed. Okay. Then this is the conditional entropy of x when y is equal to y k known. Okay. Then we can calculate this conditional entropy in this way. This is the conditional probability p x j upon y k when probability for x is equal to x k when y is equal to y k known. Okay. Now, here because this is for the fixed y k, okay, then here every term for k is equal to 0 to m minus 1, every term have some probability, okay, because that term is that symbol is fixed, okay, then its probability is nothing but the p y k, that is for that fixed y k, k is equal to 0 to m minus 1 for different symbols. Okay. Now, we can calculate h x upon y, h x upon y. Okay. Then this is nothing but the average value of these terms with their probability p y k. Then it is multiplied with p y k h x upon y, y is equal to y k, okay, and its average, that is k is equal to 0 to m minus 1. Okay. Now, putting this value of h x upon y, h x upon y is equal to this one into this expression. Now, this becomes summation k is equal to 0 to m minus 1, summation j is equal to 0 to n minus 1 p y k from here. Now, h x upon y, y is equal to y k from here, summation already taken, this into p x j upon y k, okay, into log of base 2 1 upon p x j upon yk with varying k, you know. Now, this term p x j upon y k into p y k, this is the basically joint probability p x j y k as discussed in the last slides already. Now, it becomes summation over j summation over k, k 0 to m minus 1 j 0 to n minus 1, this is joint probability, that is p x j y k into log of base 2 1 upon p x j upon y k. Okay. This is the expression for the joint entropy h x upon y. Okay. Similarly, we can find the expression for the h y by x. Okay. In that here that is also we will calculate firstly h y by x for the given x, okay, like that, and with their probability, because x will be fixed, then their probability will be p x j. Okay. And now, taking the average h y by x, here p x j h y by x, x is equal to x j. Okay. And similarly, we can calculate that can be written next, that is h x upon y already calculated, j is equal to 0 to n minus 1, k is equal to 0 to m minus 1, joint probability p x j y k into log of base 2 1 upon p x j upon y k. Okay. Now, h of y by x, okay, the same way it can be calculated with summation j is equal to 0 to n minus 1, summation k is equal to 0 to m minus 1, joint probability x j y k into log of base 2 1 upon p, this is y k upon x j, only this difference. Okay. These p x j upon y k, p y k upon x j, okay, from one relationship which we have already seen, that is p x j upon y k into p y k equals to p y k upon x j into p x j equals to the joint probability. Okay. From this we can put the expression p x j upon y k equals to this one divided by p y k, or p y k upon x j equals to this one divided by p x j, or joint probability p x j y k equals to this one. Okay. Then p x j upon y k equals to joint probability p x j y k divided by p y k. Okay. In one case, first case, we can write j is equal to 0 to n minus 1, k is equal to 0 to m minus 1, p x j y k log of base 2 p x j upon y k equals to joint probability divided by p y k, then p y k will come in numerator divided by p x j y k. Okay. In the last cases, when we have taken h of x when y is equal to y k, okay, with its probability p y k for every y k. Okay. Now, when we are calculating its average to get h x upon y, then p y k into h x upon y is equal to y k. Okay. Then this method k is equal to 0 to m minus 1, it is known as the chain rule. This is the chain rule basically. Okay. and final equation for conditional entropies we have already derived. Okay. Next class we will discuss mutual information, okay. Only mutual information remaining, that we will discuss in the next lecture. Thank you.